Hi everyone here, everyone on Twitch. My name is Ryan Lloyd. I'm a third year student here at Wilmington University in the game design major, and today we'll be talking about the Unreal Engine, namely people coming from Unity to Unreal. Now, just as a bit of a disclaimer here, I am not an expert at this. I just picked this up about a week or two ago, so I'm still learning a lot of this myself. But the reason why I decided to go on this topic was because of the fact that people that use an engine for a long time tend to forget a lot of the nuances that again we have to learn, and thus figured now would be a good time to start. And it's a journey for all of us to go through all this and learn together. And pretty much materials, as far as materials are concerned, in Unity we have shaders. Unreal Engine we have materials and a material editor to change properties of materials. In Unity we had materials. Unreal Engine 4 we had instances of materials. Particles or effects, particles, and cascade. What you have is the shuriken particle system. We have as cascade in Unreal. You have the Unity UI, which is the Unreal Motion Graphics system in Unreal. Animation is handled by Persona, skeletal animation system, and an animation blueprint, which are beyond the scope of what we'll be doing today. And for 2D, you have a sprite editor, whereas in Unity, whereas in Unreal, you have the paper 2D setup. Programming is where things really diverge. In Unity, excuse me, you have C#, Unity script, and you used to have Vue. I'm not sure if it's still supported or not. Whereas in Unreal, you have C++ and Visual Blueprint system, which we'll talk about a bit today. Physics. Under the hood, both engines use the same physics engine, which is PhysX, I believe, which is put out by NVIDIA. In Unity, where you use ArrayCast, you have a line trace and shape trace in Unreal, and rigid bodies in Unity, which are they're kind of their own component, are actually a part of your physical component, your visual component in Unreal, which are handled by like a box collision or a collision object and a physics component. So pretty much in Unreal, or rather in Unity, you have everything in your assets folder. In Unreal, you have your content folder, which is visible right here. But you don't put your code there. You put your code, if it's C++, you put it in your source folder, which is down here. Excuse me. Blueprints, however, do go in the content folder. File types are supported, just like Unity. Unreal supports FBX and OBJ for 3D objects. Texture or image types are supported. PNG, JPEG, bitmap, Targa, direct draw surface, DXR, Photoshop document, and high dynamic range. formats. Sound is supported that way. Yeah, there we go.
Of course, there's one over that side.
Okay. Yeah. So yeah, last thing I said, sound is the sound format that's supported in Unreal is the WAV format. Fonts that are supported are TTF and OTF. Videos formats that are supported are .mov, .mp3, and .wmv. Now in Unity, you have a scene file, which is .unity. In Unreal, however, you have a map file that stores your level data and data about the objects that are in it, as well as lighting and different effects. Like I said, source code files for C++ go into the source folder, whereas blueprints go into your standard content folder. Now in Unity, you're used to game objects, which are pretty much, it's a class that you create an instance of, and you use built-in functionality, components and such that are attached to that game object. The cool thing about Unreal is that your blueprint, your objects in there, your actors, are actually extensions of
Susan? No, there's no port over there. So yes, it's not working. It's not working.
Sorry about that. Alright, what I was saying was, in Unity you have game objects, which are, you create an instance of, they have all of the built-in functionality, whereas in Unreal you have actors. But in Unity, how you use C# scripts, which you kind of, they're like components of your game object. In Unreal, your code, whether it be the visual blueprint or the C++ code, is actually the actor itself. You pretty much use the object-oriented concept of inheritance, where you actually extend the original actor class and add the functionality that you want into that actor class. And you add, your visual component to that, you add your physical component to that, all sorts of stuff like that. Now, what I was saying earlier about how you don't have prefabs in Unreal like you do in Unity, what you do is you create a blueprint class, which I will show you all how to do in a little bit here, and you can actually drag objects into that local blueprint class editor to add a visual component to it, to add lighting components, any type of component that you really want to, as long as that class that you're extending supports the component that you want to add. For those of you at home and those of you here that want to go through this, I suggest going through all this other stuff here, but for now I want everyone to try and get some hands-on experience with Unreal, so what I'm going to do is I will show you how to download it. The UnrealEngine.com. Click the Unreal. Click the download for the Unreal Engine. You'll probably have to sign up with your own profile to do it and log in. It's not that difficult though.
So you drive.
What?
You drive the profile.
Say what?
Use your profile.
Use my profile? Well, I already have it on here, so I might not be able to download it. I won't be able to re-download it, but it might take a little while on its internet connection. So what I'll do is I'll jump right into the game engine itself and show you how to get started with it. You'll download what's called the Epic Games Launcher, and what you'll do is from there you'll download the Unreal Engine itself. So let's just wait for this. Okay, we're done. What you'll do is you'll see all these different tabs here on the left-hand side. Community, Learn. This has tutorials and everything for Unreal Engine. You have a marketplace which is similar to your asset store on with Unity. You can explore this. There's all sorts of assets and content that you can purchase, as well as some free content, which is pretty cool. Library, however, is where you'll mainly do your workouts. Right now I have a couple of different versions of Unreal Engine installed. The version I'll be using is the most recent, which is 4.10. So go ahead and launch that. The download itself is pretty hefty. It's about anywhere between 8 and 10 gigs. And that's mainly because of starter content. So that's why I'm not downloading it here and trying to figure out how I'm going to get running with this. And for those of you at home, I want to thank you for your patience with this. This is a new setup that we're working with, and yeah, just trying to work out all the bugs here. Alright, so for the sake of this discussion, I will create a new project. And in this project, I'll just create a blank blueprint project. Now, the reason why I'm going with blueprint right now as opposed to C++ is for the fact that the majority of people here at this college are mainly visually oriented. They're artists, designers, you know, they fall into those roles. Blueprints is a good method of development for those kind of people because it's visual. We used to use something here a while back called Stencil, and the development cycle for that was something similar to a language called Sketch, I think it was. Or no, sorry, not Sketch, Scratch. And it was, you'd have different code blocks that you'd actually drag into your code area and build up your logic off of that. Well, Blueprints is a node-based system. If you use nodes in Blender or Maya, it's something similar to that. Now, the cool thing about Blueprints is that I was talking about something called inheritance earlier. Well, you can, if you're a programmer, you can create code in C++ and expand that with Blueprints. But also, you can expand Blueprints with other Blueprints. So, cut this up. So we have a new project, new blank Blueprints. We don't want starter content in this because we don't want to deal with like the whole scene. We're just trying to create something very minimal and something very basic. So I'll just use the name presentation project here. So I'll go ahead and create this project. And we should end up with a mostly empty scene with just a floor, which is exactly what we have here. Now the control scheme for Unreal is similar to Maya and Unity, where you hold Alt left click to look around, angle. Alt middle mouse to pan your view, and Alt right click to zoom in and out. So what we have right here is a single object, which is our player start, which is something that's built into our game mode, which is a part of the Unreal gameplay framework, which is something I'll cover in a later presentation. So what we're going to do here is create a blueprint. So what we'll do is click on this Add New button in our content browser and click Blueprint Class. Now, what you'll have is this window pop up here that says Pick Parent Class. Now, like I said before, I've said this a couple of times already, Blueprints and C++ classes in Unreal extend a object itself, so in essence they're a type of that object that you extend. So in this case we want to create something that we can control from a controller or the keyboard or mouse or whatever. So I'll pick a pawn because that's the most basic player type or AI type in Unreal. So I'm going to select that, and then we'll pop up with my new blueprint. I'll name it My Player. So now I double click on it, and we pop up with this little window here, which is our blueprint editor window. We have our own visual area here to see this blueprint. The instruction script is similar to the on-await function in Unity, where right when something is created, it gets that, or not when something's created, but when something's spawned, it gets that property that you set up in here in the script. But this also has the added advantage of it edits it in the editor itself. So before it even is run in the program, what you do in this construction script will change the beginning of the object. Like if you wanted to add a particle effect, it would instantly be applied. Now here's your event graph where the meat of what you're going to be working with here is. so. Alright. Yeah, so pretty much any code that you do for this blueprint, for this object, will be done in this event graph here. So pretty much, in order to move around in here, you just right click, you don't hold Alt or anything. Right click to pan around. Hit Alt, right click to zoom in and out. See what you're being able to do. And yeah. Also you can left click, drag to select numerous objects, or you can just click to select single ones. So to get going with this, what I'll do is I will go ahead back to my regular editor here, and as part of the gameplay framework, you can edit the input in the editor itself, similar to how you can work with it in Unity if you so desire. So I'm going to go ahead and into Edit and click Project Settings. Under Engine, I will click Input, okay? So then you'll have this area here called Bindings, and you'll have Action Mappings and Axis Mappings. Action Mappings are pretty much single key presses. Axis Mappings are like control sticks on like the controller, you know, movement keys, you know, for moving around, stuff like that. So what we'll do here is add a couple of axis mappings, which you do by clicking this plus button. We'll create one called Move Up Down. And when we expand that, we have our selection for our key values. In this case, I'll just use the keyboard, set W, and add another one for S. And also we have the scale here, just like you would with Unreal. I'll set down to -1, up to +1. And then what I'll do is I'll add another axis mapping and call it Move Left, Right. And what I'll do is set that to A and B, respectively. What we'll do is we'll set A to -1 for the scale, because we'll be going in the -X direction in our 3D space. So pretty much what you have for people who are familiar here with programming is something like a hash table or kind of like a tag for your input. And that's because your input here is built into the event system of Unreal. In Unity, event or input is pretty much like a static function call. We use like input dot get key down, get key up, stuff like that. In Unreal, whenever a key is pressed, an event is triggered, caused by this axis mapping. So what we'll do is exit this window, go back into our blueprint, and right here what you see is, you see 3 different events here. Event begin play, event actor begin overlap, and event tick. Event begin play is similar to your start function in Unity. It is called at the first frame of your object's life. And after that, you have event tick, which is called similar to your update function. Now, what's cool about this is in Blueprints, you don't have to handle delta time directly because Blueprints handles it for you. You do have this delta seconds here, which you can use if you ever feel like you need to, but thus far I haven't had to use it. So what I'm going to do is right-click in here to try and create a new node. This is a node-based system, and I'll walk you through how to do stuff here. All right, you have all of your different actions here for this blueprint that you can use. You have actor components, add component functions, add events. What we're going to do is we're going to add an event here, and what we're going to do is select okay, so that's not popping up. What you want to do is you want to type in here, because like I said, I'm still getting used to this layout. In that search bar, you want to type in your axis binding, which in our case, we're choosing move up down. And then you want to choose the axis event move up down. What that does is that creates your event, which you can then use to attach code to. So do that for axis move up down, and you'll see two different nodes here that you can work with. This execution node, which dictates the flow of logic in your program, and your axis value, which is the current value that you're getting. So if I were to press W, this event would be called, and it would give me an axis value of 1. If I were to press S, this would be called again, but instead we'd have an axis value of -1 to fit what we're doing. So what I'm going to do is I'm going to right-click here. And I'm going to type in add force. That's why. Okay. I'm going to back up here a second. I apologize. What I'm going to do is go into the viewport. Something I should have told you all about beforehand. Right now all you see is this sphere. That means that we don't have a visible component on this actor. Like I said before, the physics component and your collision components are tied into your visible component, your mesh. So what I'm going to do is I'm going to click this cube over here from our different nodes, from our content, and drag it into here. And you'll notice now that we have a visible component on our object. And you'll notice here as well that we also have a details panel like we do in our editor, and we also have graphs, functions, macros, variables, stuff like that, as well as our component setup for this. On our component setup, we have our cube selected, and we have the set to a static mesh, which is a cube. Now we have a physics component attached to our object as well as a collision component. What we're going to do is we're going to select simulate physics, select mass in kilograms, change that to 100. Now the physics engine in Unreal uses centimeters for distance as opposed to meters. Everything else that you have in Unity is pretty much the same as Unreal. You have kilograms for mass and seconds for time. So what we're going to do now is go back into our event. This isn't what we want. We're not going to control this. There's a reason why this is happening though. It's because it's our basic game mode. So what we're going to do, create a new blueprint and have it extend game mode. We'll just do my game mode. Now what we do is we go into our blueprints here, project settings, game mode, and select game mode class, my game mode. You want to set the AI controller to player controller, input set to player 0. And move back and yeah. If you notice our cue rolled back when we press the back button. So what we're going to do now is, so we can actually see what our cube is doing, we're going to add another component here. We're going to add a camera component. We're going to child it to the cube. Now for this camera, what we're going to do is we're going to move it up. It's need to rotate. It's just like Unreal, just like Unity and just like Maya. The QWERT system to change your different tools here. Once you compile this and the change, you'll notice also happens in here. This is odd. Alright guys, give me a moment while I work on this. Okay, I think what I needed to do was set it to auto possess player, set it to player 0. There we are. And it's not moving at all because of the fact that we need to set this value. Like I said, it will be a very small value due to the equation, so add in another 0 there. So you're working with 100,000. I thought I already set that to 100,000, that's weird. Hit play. Yeah, I broke it. That's the fun thing about this. When you break something, then you have to figure out how it worked or what you did wrong. What we got? Huh? Exactly. What we want to do is, like in Unity, how you can set constraints on your rigid body, in here you want to go into the physics portion of your cube, and you'll have this little thing here where you click and show constraints. What you want to do is you want to lock your rotation on your X and Y. The reason for that is because, unlike Unity, your Z-axis is your up axis, your X-axis is your right axis, and your Y-axis is your forward axis. So go ahead.
How much data is being recorded on here?
Yeah. This is where the issue is. This is something I also overlooked last, when I first started with this. And it's, we need to multiply this axis value by what we're working with. So what we're going to do is right-click this, type in float times float, get that, drag that over to here, this axis value over to the first portion of your multiplication, take this, copy this value, paste it in here. Drag that over here so these two are connected now. Compile. Just for kicks and wins, change that to 500. Save. And now we're moving. And we fell off the world. Mission accomplished. Our cube died. So now what we're going to do is create another event, which is we're going to type in input axis, move, left, right. And what this will do is this will do left and right. The cool thing about blueprints is that we can select all this stuff that we did right here. Right click, copy it. Or not even that, we don't even need a copy. We can copy and paste, or we can click duplicate. And we have a duplicate of everything that we did. We'll drag that down here, move everything down here, move this down here. Go in here, delete get forward vector, delete that cube. What we'll do is we'll type in get right vector and select for our cube. So now we have that. What we're going to do is drag this return value over to here, similar to what we did with the forward vector. Drag this axis value over to here, and then we're going to take this execution node and drag it over to here so we execute this add force node. And what we're doing is we're adding this force here that we're setting up through this right vector times this, 500,000 units of force, which in our case, is really 5,000 newtons. If you think of it in terms of physics, because we're dividing this acceleration value, dividing that acceleration value by our mass, which is 100 kilograms. to get this force. So now we compile this like we otherwise would. Play, and then left, right, up, down. And so we're going to stop this now. We have all this. That's pretty freaking sweet now that we can control a object. But the problem is we don't have anything to stop it from running off the floor. What the hell are we going to do about that? Well, we can do what we do in Unity, which is create a cube, should create a cube. Oh, yeah. Like I said, I'm still totally new to this. Still learning this. So what we do is we select the cube, hit the R key to switch to your scale up, scale right. And then what we do is we click simulate physics, enable gravity, set that to false so we don't fall through the floor. And then we lock our position, and we lock our rotation. And what we do is we'll shift, right click, duplicate, do that down here, and then we'll Control W to duplicate it again, only this time we're going to rotate it by 90 degrees in our Z axis, which will usually be our Y axis in standard mathematics and Unity. And then what we're going to do is Control W again, duplicate this. So now we have a walled in area. Save this. We haven't saved our map yet, so what we're going to do is go ahead and do that. We're going to do test map just for the hell of this. Hit save, and there's our map popped up in here. Now you'll notice also that we don't have a source folder in here because of the fact that we didn't create a C++ based project with this. What you can do is, if you want to be able to use both blueprints and C++, I think our next workshop here will work with C++ in Unreal. You'll want to create a basic C++ project. But also they gave you a whole bunch of different templates. First person template, third person template, vehicle template, side scroller template, 2D side scroller template. All of those things that you can play with and learn more about, and you can just throw assets in there as you need to and create something really quick, good for rapid prototyping, just like blueprints. So now we're going to go ahead and click play. We're going to do that. We have simulate physics, okay? But what the hell? Why doesn't it collide? What's wrong with it? There's a separate collision object or component here. Not component, but collision property, I'll say, of our cube, which we need to select to have it work. So we do that for each one of these cubes here. I don't know why. And actually, if you want to see, the world outside of what you have, what you do is you click that eject button, and it'll show you everything that you have. So we're going to stop this right now. And what we need to do in our player is set it to, make sure that's set to collide. So we resolve this. But what it could also be is the fact that these are going through the floor. So what happens is when this runs, if you notice they were angled out. So what we're going to do here, just to test it. See this, this. Yeah. There we are. Now it works as it should. What happened was, it was generating a collision error because of the fact that we had these going through the floor, which kept focusing on that one collision, as well as them colliding with each other. So what we're going to do now, so let me take this. Bring this over here. And what we're just doing at this stage is just some rapid prototyping. So it's just a demonstration as to how things should work on here. So we select that, select that. Save, build. It's dark. It's dark. You can't see what I'm doing. That's fine. Well, let you compare it to this. To our head. Well, that spotlight's fine. So what we're going to do is we're going to take that spotlight that we just added. Spotlight that we just added, bring it up. And slightly off angle just for 50 grams. Oh, we're doing that nice, but bring this over, compile it. And now, you'll notice that we added this to our player. Now he has his own light attached to it. something funny about this. The light doesn't really follow him. That's because of the fact that, like I said before, your physics object is your visible object. If you look in your hierarchy right here, you'll notice that the light is not attached to our physical object, which is our cube. So what we're going to do is we're going to parent the cube to the light, compile it just to be safe. Now reject. Yeah, and you'll notice that it follows. Now the lighting's not as bright as I'd like it to be, so what I'm going to do is set its brightness to something very freaking big. And we'll set that out a little bit. Like that. You can just play with this stuff, compile it, save it, run it. And you'll notice it's a bit brighter now. So that was pretty much all I had planned for this intro to Unreal. Where you can go from here, the manual is a very good place to start. There's a lot of documentation in there, for blueprints especially. It's really nice. I'll cover I didn't cover the gameplay guide in this presentation due to technical difficulties, lack of time, and quite frankly, it's a lot to go into right now. And there are a couple of bugs in the documentation itself. One primary one, which for those of you who are going to look into this further, is in the blueprints portion. In the blueprints user guide, flow control. What they have set up for the while loop will not work at all. In fact, what it will do is it will completely ignore that loop. It will go past this portion because it's never set to true. And it'll just, complete correctly. But aside from that, the documentation has been pretty good. I'm thinking next week I'll cover a bit of how to work with C++ in here. Or not next week, but the next time we do this. And then the following time I'll cover the gameplay framework, which is not something that's in the community, but it's a really valuable asset for a game developer in Unreal. It allows you to do all sorts of stuff, including network coding, very easily, because it's all built into that framework. And also it helps handle game management, game rules, stuff like that, game states. Yeah. So again, my name is Lloyd. I thank you for listening to my rambling here, and I hope you all gain something out of this. Thank you.
What was that again? say
We're gonna do a new stream.
Yeah, we're gonna do a new stream, and this time Jeremy's gonna talk about everything.